Hi, cool coders. Today we're going to be looking at how to do lambdas in Python. Now, we've looked at functions in the past, and lambdas kind of build upon this same idea. They're basically shorthand functions, and they can be used in line with code, while with functions we had to basically create a definition that was outside of the main body of our code. With lambdas, you can put these in line and do some other cool things with it. So we're going to go into the content right now and look at these and see how you can use them in your code. So buckle up. It's a pretty fun but short lesson on this particular topic. Okay, let's first get our heads around what is a lambda. A lambda is basically a short function like we've seen already. We've seen functions and we've declared those using a name. Now, a lambda takes kind of the essence of a function and collapses it down into a single line of code so that we don't have to have multiple lines of code to do certain things. And that's kind of what a lambda is trying to get at. But there's some other nuances. We're not going to get into the details of why these are, but we're really just kind of to expose you to this idea of a lambda. Lambdas are also called anonymous functions. Now, we declared functions when we looked at those last time with a name, and we'd say function name, and they would have arguments that would come with that. And a function in a lambda syntax doesn't have a name, but you can assign it to a variable, and then that variable will then point to a given lambda. And that's why it's called anonymous, because the variable can be anything, or you don't even have to assign it to a variable. It doesn't have a name, so it's anonymous, just like an anonymous person doesn't have a name, or at least you don't know their name whenever you're addressing such an individual that is anonymous. And they're typically short, one line of code. So anytime you use a lambda, you're basically going to be using these four things that you're going to be doing over and over: single line calculations, concatenations that are very common in your code, these kinds of things that you're going to be using that require only a single line of code. That's a great use for a lambda in your coding. And it can also help make your code a little bit more readable, so you don't have these long calculations, for instance, copied and pasted over and over in your code. Rather, you can just use a lambda, and then you can concisely call that lambda in your code rather than having to have a bunch of verbose code that is encapsulated in a lambda. And the anatomy of a lambda looks something like this. We have the lambda keyword, and it's going to tell Python that we're using a lambda. And then we're going to have arguments, just like we saw with our functions. And those arguments are then used over here in this expression. And that expression will then be returned. So there is an implicit return, even though I don't have it declared. The value of that expression, or whatever comes out of that expression, will be automatically returned rather than having to explicitly define this. So again, this is a complete function. It's just in a single line, and we have everything that a function would have. We have arguments, we have an expression, we have a return. It's all in one line of code rather than having to do it with multiple lines of code. Additionally, when we look at lambdas, the reason that we want to use these sometimes is so that we can have concise code, but they have a lot of the same principles as a function as we saw on the last slide, but you can also use multiple variables. So let's say I had this function right here, and I had a function called add, and it simply returns x plus y. This lambda right here is functionally equivalent to the first function that we had defined right here. So if I was to do some highlighting here, let's do some work with our pen right here. This is the name of my function. Because lambdas are anonymous, I don't have a name. Here are my arguments or my parameters, and here they are down here. And then here's my return. This implies a return, so I don't have to use that return keyword. And then there is the expression, and here's the expression in my lambda. So side by side, you can see that everything is there. So let's go over to Tony and build something that looks like this. Let's build a function that is computates something, and let's build a lambda that'll do the same thing, and just see how they look in the code and just run them so that we can get an idea that a lambda is really just a function that's kind of shorthand. Okay, let's start with a standard function, and I'm going to call this a multiply. Let's call it mult for short, and I'm going to give it some parameters of x and y. Just call it x and y, and I want to return, just simply return x times y. So that's fairly straightforward, and so I can print mult, let's say 2 times 3. Okay, there you go. And that should print out 6. So that's exactly what we got right there. So that is a standard function like we've seen already. Now I'm going to do this with a lambda. So the first thing I need to do is create a lambda. So a lambda is typically either inline or assigned to a variable. So if I have a variable, let's just call it m, I can use an equal sign, and then I can declare lambda like this, Lambda, lambda, and then as part of this lambda, I can have parameters. So I'm going to have x comma y, and then I put my colon. And that is what sets up more or less the signature like we saw up here. So my name and then my arguments and my parameters right there. And then I have an implicit return. So I'm just going to say x times y. So that is a lambda in Python. That is more or less functionally equivalent to what we're seeing right here. So let's go ahead and call this. So to call this, I can then point to m. So m is pointing to this lambda. So I can go print m and then pass in parameters just like I did with my other function up there. So 4 times 5. So that should return 20. And so let's run this. I should get an output of 20 right there. So I'm using a lambda right here in doing a function that's in line with the rest of my code rather than having a separate block of code to define that. And I'm referencing it with a variable. Now I don't have to have a variable here. I can use lambdas without variables, and we're going to look at an example of that. But this is a pretty straightforward example that it shows you that we have essentially a functional equivalent between this lambda and this function, and we're just calling them two different ways right here. So I'm calling the function explicitly right here and then calling the lambda right there. So again, functions and lambdas are very similar to one another, and so that's why I'm introducing this as a build upon the last lesson, which is a lesson on functions. Now we've looked at lambdas already, and we kind of went over that pretty quickly because it's pretty straightforward. They're really not that complicated once you kind of understand what they're doing. Now, the map function, on the other hand, is a little bit harder to get your head around, and I want you to pay attention to what I'm saying here, probably more than anything when I'm talking about other than the lambdas, because lambdas are pretty straightforward. But the map function is a little bit more tricky because it is used as a way to create implicit loops. And when I say implicit loops, I'm talking about a loop that is used in Python that's not explicitly defined in our code. So we're not going to see while or for. We're not going to really even see recursion. What we're going to be seeing is a loop that is implicit by the fact that we're calling a map function. And so the way this works is we have a map function that's declared right here. And then what happens is I take the map and I pass in parameters to it. The first parameter is a function or a lambda, which in this case, I have a lambda declared right here. And that's pretty straightforward. It's a lambda that multiplies x times 2. Now, the last parameter in this is a list. It can be a tuple or a range. It's basically any kind of sequence of numbers or parameters that we want to use. So this list then, when I declare a map, will then be used to parameterize the function or the lambda that I pass in right here. So when I call this, the first time it goes over this list or this tuple, it's going to pass in the first value to x, and then it's going to output that to the output, which is actually a map object, but we'll look at that in just a second. And then it's going to repeat that for each item in my list right here. So I can continue that for the entire list. So this is basically implying that I want to call this lambda function right here with all of the values in my list down here. And then it's going to store the results of that. Remember that lambdas have an output. It's going to restore the results of that in a what we call map object, which is essentially just another kind of list. But I can then take that map object and I can convert it to a list right here. So that's what I'm doing right here is doing a cast to a list using the list keyword, and then it's going to then print that list out using the print keyword or the print function. So what this is basically going to do is give me a list of numbers that are going to be multiplied times 2. So it's going to be 2, 4, 6, and 8. So let's go over to our IDE, Tony, and then write this up, and then you'll be able to see what I'm talking about and how that actually works in our code. Okay, I'm here in Tony, and I want to create a Lambda function using map. So let's see if we can basically reproduce what we had. Let's change it up a little bit, what we had on the slide, but we're going to change it up a little bit. So what I want to have here is a variable. I'm going to call it m, and that's going to be equal to a map. And then inside of my map, the first parameter I'm going to put in is a Lambda function. So I'm going to put in Lambda, and I'm going to put in some argument, and then I'm going to then use a colon, and then I'm going to do something with that argument. So let's multiply, let's square it. Let's just do x times x, like that. So that's going to square x. So anything times itself is a square. And that is going to return x times x, so the square of that. So let's then create a list of numbers, 1, 2, 3, 4, 5, 6, and 7. And let's close that up. So what this is going to do is square all of these integers that I have inside of this list right here. So let's call this squares now for my map. And then let's print this off, print squares, like that. So we basically just typed up something very similar to what we had in the slide, but I want you to watch the results of this when I run this. I need to cast that to the list, because otherwise it's just going to give me an object called a map object. So there it is. Let's try that again. And notice what it's doing here. I have my return as 1, 4, 9, 16, 25, 36, and 49. So what it's doing is it's taking 1 and then squaring it, and then putting that output into my squares variable here, and then it's 2 squaring it, and then putting that output into my squares variable there, 3 squaring it, and then putting it out into my squares variable, and so on until I get to 7, which is 49 when that is squared. And then this is simply doing a cast to a list and printing that out onto the shell or the console down here. So this implies that there's a loop going on where I have a loop that's going over everything in my list right here, and then passing those in as arguments into my Lambda, and then writing the results back to this variable right here. It's called squares, and it returns that as a map. And then I'm just casting that back to a list right here and printing the results. So this is a fairly straightforward concept, but for folks that have never seen it before, it can be a little bit hard to get your head around. But it does give you a way to create very concise code. And with this, I don't have to have a function declared. I don't have to have a separate list declared. I don't have to create any kind of looping structures for this. I can have very concise code by doing this. So this is one way that programmers are able to create very concise code in their code without having to write a bunch of superfluous loops, when you can do something that's fairly straightforward like this with maps and lambdas, so that you can have just nice, clean looking code. And once you understand what it's actually doing, you can get your head around it and you can understand what's going on. But this, in my mind, is a very simple, elegant program that does something that would take multiple lines of code. If I was doing it more manually, I would have to create a list, create a for loop, and then print out the results of that for loop, and so on. So this is just very concise code that does something very pretty rudimentary, but that's kind of what it's for, so that you don't have to do a lot of these kind of rudimentary tasks whenever you're doing things with like lambdas and maps. So let's go to the challenge for this week. It's been a short lesson on lambdas. I basically just want you to create a dice simulator similar to what we did last week, but I'm not really interested in you creating a controlled input. I just want you to create a lambda that simulates a dice roll, and I want you to be able to do this in very concise code. So I want you to use map and Lambda together to create a dice roll simulator, and that basically should be about 1 or 2 lines of code. So very easy challenge, or maybe not so much. I don't know what it'll be, but I'm looking forward to see if you can kind of figure out how to make that work. So I don't want you to use loops or functions to do this. I want you to basically just take what we were talking about with our maps and our lambdas, create a simple lambda that will simulate a, essentially a random number, and I want you to call that 6 or 7 times, however many times you want to call it, and then print those results back to the screen. So let's go over to Tony and see my result and see what that looks like. Okay, here is my example. It is 3 lines of code. I can give you a little peek down here. If I scroll down, I'm using random there. So that's one of my lines of code. The other 2 are just the map and lambda, and then the print result that I'm looking for there. So that's kind of what I'm looking for, is some very concise code that will essentially just give me a list of random numbers. So in mine, I'm asking for 6 random numbers between 1 and 6. So it's essentially the roll of 6 6-sided dice. So if I wanted to change it up and add it and make it 7, I would change one of the things in my code that would make it 7 or 8 or however many I want to roll, or however many sides of the dice I want to have. A coin flip would be 2-sided, of course. So you can write code that does this, but I'm looking for how concise you can make it. You might be able to do it in 1 line of code, maybe. I mean, it is possible to do it in 1 line of code. I did it in 2 lines of code to make it a little bit more readable, but you could definitely do it in 1 line of code if you want to do that, other than the import random, of course. But I want to see you create a program that's very concise using what we talked about with lambdas and with map, and I want you to be able to run that and just get a list of random numbers similar to a dice rolls like we have here when I run mine. So looking forward to your submissions for this particular challenge. I know it's a very simple challenge, maybe not so simple challenge, very concise, but it will be fun to try to make your code as concise as possible rather than having very verbose code. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron on our page by going to our Patreon page at patreon.com/coolenoughToCode and then clicking on Become a Patron, and there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.